really looking forward to this feedback loop that we really need to understand if AI is truly helping us in our production code or not. So please welcome on stage Justin Cormack.
Cheers. Nice to be here. Great event. Hi to everyone who's online as well. I love tests, and I've always liked tests. So with AI, I've enjoyed thinking about testing a lot more. I live in the east of England, in the middle of nowhere. This is our local infrastructure. This is a Roman road. This is what happens if you don't maintain your infrastructure. I love infrastructure software, and it's kind of my thing. And a while ago, middle of last year, Minio stopped maintaining their S3 clone object storage product, and lots of people complained and said, we like this product. And I'm very obsessive about object storage. I gave this talk at KubeCon a few years ago. It's one of the most watched talks from KubeCon about object storage. And earlier this year, I was kind of looking for a project to experiment with this. I wanted to understand what happened if you tried to use AI to write really large, complex systems. Because it was great fun writing small tools with AI, and you could write them really fast in half a day, and it was exciting. But could you really build huge things? Object storage, to give you an idea, most of the implementations I've looked at take around at least 2 years to write, some of them a decade. These are big projects. And so I thought, well, how hard could it be? I might just give this a go. Maybe I can do it in a week. And I knew this was going to be a big project. I was kind of excited about writing a big project. At the moment, it's 350,000 lines of Rust. So I knew I wasn't going to read the code. I have only ever half learned Rust anyway. And reading the code is kind of annoying. It's going to be huge and complex, and I don't necessarily need to understand it all, but I know I want high-quality code, and that was my thing. And I knew there was plenty of scope for things to go wrong. I was building distributed systems, complex stuff, and I was going to reverse engineer this entire thing by talking to S3 and seeing how it works with my AI. So it was like this was going to be kind of fun. I knew I wanted to broadly understand the code and be in the loop always and really understand what's going wrong. I had architectural opinions about how I wanted it to work. I didn't want the thing to collapse into chaos as it got larger. I mean, I talked to a lot of people who said, yeah, after 100,000 lines of code, the AI can't do anything anymore. It's terrible. Give up. I've worked in security a lot and performance engineering, things like that, and so I've got opinions about security, good. And I was trying to not automate everything up front because I wanted to know what went wrong. So doing a real human in the loop thing. And the other kind of question I want to answer for myself was what can we achieve with AI coding? Can we be really ambitious and build things we never would have tried to build? I know people who build database startups, and it takes a decade, and it's kind of a hard slog. It's like, if we can do this in less time, we can build more of these interesting systems that I like building and using. So that was what I tried to find out. And I like this quote from Deming. Deming wrote about quality, and he introduced quality control to Japan after the war. Inspection of quality, I know, looking at the lines of code does not actually find the bugs. We know that. And so you have to build quality in as you go along. And one of the important things to do that with, obviously, is testing. And so I was like, well, I'm going to build lots and lots of tests. And just using testing, I think, works really well on small projects. When you're doing a small AI project, you can really, really test it extensively. You can be, kind of ruthless about it, and you can be pretty happy that it's actually working for you and that, it's simple. But once you get into these larger projects, testing gets more complicated, I found. especially when you get into distributed systems, you get into race conditions, and you get into weird things we'll talk about in a minute. And I keep hearing people say, well, with AI, all you need is 100% test coverage and you're done. And it's like, but I did try that. I started off trying to get 100% test coverage. It seemed like a good idea. And I also measured different measures of test coverage from integration tests. And it didn't really help a lot. I found they were kind of better uses of my time than trying to get 100%. I sat down and I asked AI agent to get 100% test coverage. It kind of wrote trivial tests that I was like, this is a stupid test. I don't care about that. And there's also a lot of weird error cases that are really hard to cover. I mean, I went through and asked the agent, like, well, why haven't we got 100% test coverage from this? It's like, we don't have a test for when the random number generator in the system fails. And I was like, yeah, I don't think I want to write a test for that. Like, that's just too much error injection. Like, I can see that there's it's gonna give an error or it's gonna panic, and that's the right behavior. I don't need to have test coverage for that on all my test suite. But I still have a lot of tests. I mean, 75% of my code base is tests. Test coverage is between 75 and 100% for each file. Like, it's like you can still have a lot of tests without being really obsessive about 100% test coverage, which I think is not really the right kind of aim. The great thing about copying an existing system like S3 is you've got this test oracle. You can find out what happens when you do something. You run the test. You can run it in my case against S3, and I have 1,500 tests that run against S3, and they lock down the behavior. Then you tell the AI, you have to do it exactly like that, and it's much better at doing things when it does that. It basically gives it a nice baseline. It's so much so that I actually think that if you're writing a complex system, the one way to start is to write a really, really simple version that's kind of trivial, that basically has the same behavior that you can use as this test oracle, so that when you're building the more complex version, you don't make it break. And you can build a test suite against a simple version first. It's not 100% easy. Like, you pointed at Amazon S3, for example, and you discover all sorts of kind of weird things, like S3's authorization is, a lot of it's eventually consistent, not immediate. So you have to keep working out, well, we need a load of retries in this test, otherwise it looks like the behavior is different and things like that. And so you have to kind of do some interpretation, even with a kind of exact text oracle, which is kind of annoying. So it's not quite a specification, but it kind of does keep you very, very grounded, which is really important. The other thing about having a test oracle of something you're trying to copy, whether it's an existing system of yours or someone else's, is that the public API doesn't cover behavior you can't really see that goes on in the background. And so you can't tell when things happen or invisible behaviors about things. You have to kind of either infer them from something you can observe, or you need to find some other way of testing those kind of behaviors. So, you can't see when an item really gets deleted in S3. It kind of happens at some point, but you can't. There's no API that lets you see behind the scenes of that. The other thing, you think S3 is really nicely documented. It's got all these hundreds of pages of documentation. The documentation turns out to mostly be wrong in every single detail when you actually look at the details. So again, having the test oracle and running the test is much more important than reading the documentation. I think the documentation, maybe it was true once, maybe it's approximately true. It kind of gives you hints about things that are interesting, but Never trust anyone's documentation at all. But again, that gives you grounded tests on what real behavior is and real edge cases. Edge cases are really interesting because they kind of, it was kind of a while in when I found, when I was actually working on improving the type system in the code, and the AI was writing some test cases for this, ran them against S3, and found a 500 error, which was repeatable. And that was kind of quite exciting because this was an interesting edge case that had come up. It was implementing the code, and it just thought, well, I'll test this against S3 and see what happens. And clearly, Amazon did not have a test case for this, and I did. And it actually gave me confidence that I was fine. As soon as I found that, I was like, my test suite's actually good now, or parts of it are good now, because I'm finding really weird errors. And really weird edge cases. That means I must have kind of explored a lot of the universe of testing. And it's kind of weird when you're doing this kind of complex development, because sometimes you feel everything's terrible and everything's really bad and like this is never going to work. And then other times you feel, oh, actually, yeah, this is kind of working again. So this was kind of the kind of thing about testing that gives you this kind of confidence. I found another repeatable 500 error later, another weird edge case, and I was like, oh, okay, wonder how many of these there are. Only found 2 so far. AI was quite good at the edge cases, particularly kind of when it's actually writing code itself. I kept finding edge cases by reading the AWS documentation, thinking, is that really true? Have we got tests for this? Asking the AI to write tests for them, and finding other weird things that were approximately equal to the documentation or hints from the documentation. When I pointed the AI at the docs and asked it to do the same thing, it was really bad at that. It seemed to not be able to look at docs and find edge cases in the way that I can. So that was kind of interesting. But sometimes if you asked it to find, sometimes I found edge cases through test coverage issues, like make sure we've got improving test coverage, we'll find some edge cases, just asking it to think about the usual kind of edge cases, like 0 length and 1 length and 10,001 length and so on helped a bit. But there's, you kind of have to iterate through these things and kind of think like a QA person, think like a tester yourself, and have some ideas about areas that might have weird errors. Flaky tests were really interesting. I said that like AWS converges to truth over time, which is really annoying, and this wasted a huge amount of time. AI's like, never have flaky tests with AI is my hard rule. Just fix them immediately. Weird things go wrong. Sometimes it decides that the training data says that developers never fix flaky tests, so we ignore them. And I then shout at it and say, no, in this code base, we fix our flaky tests. It says so in the agents.md file, and you're ignoring it again. But somehow the training data says no one fixes flaky tests, which was definitely true. I've worked in many places that had a lot of flaky tests. Sometimes with the AWS test, it decides that AWS changes their behavior every day. We'll just change the code to match again, because we must match AWS's behavior. And then it's like, oh no, it's changed back again. Okay, well, we'll change that again. And it's like, no, there's something wrong with the test. You've got to fix the test first. So that was kind of annoying. So I would absolutely this is the opportunity to fix flaky tests. AI is good at it, and it will really help your tests if you just get rid of all your flaky tests. And also make your tests as fast as possible and run them a lot. You'll then find the flakes much quicker because most flakes don't happen that often. I currently have 5,000 tests that run in 2 minutes, and that's kind of 2 minutes is my kind of a borderline acceptable. I might try and speed them up again, but it's like that's to me that's okay. But they have to run. You're running them a lot, and so and you need to find the flakes. And sometimes with certain kinds of change, you get a lot of flakiness, and then I've spent I've set off overnight runs, doing repeated test runs to try and find errors on multiple machines and things like that. So, it's not nice if it's slow, or the tests that really are flaky for some reason. AI is great at all sorts of kinds of tests. I basically, every now and again, I would ask it things like, what kind of tests should we have had to fix those issues we just had, and it would come up with new kinds of tests. And many of them found issues. The fuzz tests were good. The property-based testing found some issues. So I think you can do things that you might not have ever thought about before. There's lots of great kinds of testing that are available, and you should try them and see how they work, and have more kinds of tests as well. What tests can't find is important to know and understand. Sometimes they can find race conditions, and again, the more tests you have and the more faster they are, the better, but it's hard. Performance tests, we'll talk about it again in a minute. It's hard to have good performance tests on an ongoing basis, but you can do it. You can't find security issues with tests. You can't decide if your architecture is good with tests. And if you can't measure it right now, you can't really test it. Or so there's lots of things that you have to kind of think are outside your tests and try and work out how to get them inside. And that's you've got to be thinking about these issues that your tests are not finding. And again, that's why just focusing on test coverage means you're not thinking about security enough. To make things more testable, you've got to think about things that, any kind of signal you can get out of the black box, basically. If there's a meowing noise, then it's giving you information that you need to know. Increase the scope of what you can test, build more testable interfaces. One thing I kind of regret doing is not really building the management and reporting and back-end interfaces, because I could have run the tests on those to understand what's going on better. I was really focusing on the public API because that's the thing I felt I was trying to replicate, and not the internals. I have unit tests on them, but the APIs are kind of internal and unstructured, and I don't necessarily know how much I trust them because I can't see them. I can only see them through testing, and I can't sit there and play with them. So I kind of the more you build out, the better. Tracing and classic observability pieces. I discovered that even just getting the AI to build a hand-built, hand-maintained tracing framework was incredibly useful. You don't need to tie it into production system or something, but anything that can give it traces that it can look at to debug is amazingly useful. In this case, it had a bunch of overhead, so when I used it for performance testing, it was a little bit misleading, but it told it, basically gave where the big performance gaps were. And it was incredibly useful for debugging because I could give it, I could run the test, I could have my test suites running looking for race conditions or errors, give it a trace and say, this happened overnight in my overnight run, we need to fix this. And it would let it actually lock down on what the real problem was rather than trying to guess. Because if you if you give an AI a bug, but you don't know how to repro it, and it's a rare condition, it can waste a lot of time. It can either fail to reproduce it itself, or it can guess what the solution might be and get it wrong or something. And if you can give it a trace and some trace tooling and just get it to sit there and try and reproduce it and itself and see if it's the same thing, then it usually can, and that works really well. So you don't need to necessarily all hook it up to a production environment. You can really do this just by getting the AI to build some tracing tools for you. Performance testing, I found the AI is very much like human people doing performance improvements. Like, you build something, it wouldn't improve the performance or it'd make it worse, because it would think, this must be the way to fix this, and it's not. And that's just the way of performance engineering, to be honest, and kind of lean into that. Just remember, this is cheap, low-cost work, and you just throw it away if it doesn't work. Don't do it just because it seemed a good idea and keep it. It's like generally just say, no, throw that one away and try something else. Comparing performance against other systems was quite fun. I did some performance testing against one of the other S3 implementations, and got the read performance to be the same, and that was nice. And then it was like, why is our write performance really slow? And it spent a bunch of time thinking, and eventually it said, they've got a comment in the code saying we don't f-sync when we actually write. And I was like, okay, well, if you don't f-sync when you write, then of course it's going to be faster. Start wasting my time trying to actually make performance the same as something that's doing something we don't want to do. So, it's a good tool for that. Other things. I had a lot of issues early on with how permission checking worked, and time of check, time of use, testing permissions twice in different places. I tried tracing these and fixing some issues, but I ended up just telling it to fix it in the type system instead of actually trying to use tracing or anything to do this. Like, have an authorized request type that can't be reauthorized. Make sure that all the things going into, at this gate are all authorized. All these types of functions take authorized requests, and then just force everything through types. And that saves a lot of effort. And once you've constructed it so you don't have to have a test for this anymore, because you know that the types are enforcing it for you. And I spend a lot of time like looking at the interface types between modules and just seeing if they looked sane. Security reviews, I like Codex security. I found a lot of issues. What I do with them is I check the findings into the repo and ask the AI to review them. 3/4 of them are valid. They're not necessarily 100% security findings. And then I would, every now and again, I'd do review sessions for like, how could we have avoided these? What tests should we have that would fix these? I found it really valuable because although I do a lot of AI code review at the time and find a lot of issues and do a lot of review iteration, it still found things that had been missed that were actually important and really quite, kind of major things. So and so I've done more kinds of AI security review as well. I mean, Codex security reviews pull requests, which is fine, but you also want to sit down and just review the state of the code as it is as a whole and look for issues and so on. I found those have been very valuable. As I said, human in the loop. I view myself as part of the feedback loop. I have opinions, and I'm here to find out what's going wrong. And so I've been not trying to automate things too much because I want to actually understand what's going wrong in order that I can, because I'm responsible for the quality, and I care about the code, and I want to know it's good, because that's my kind of aim with this. So I kind of view myself as part of that. So what did we learn? So a test oracle or model is really useful. And copying things that exist is actually a nice activity. That's long history of open source projects doing that. The GNU project was there to replicate Unix and so on. And it's a great activity to do, and it's kind of good fun, and it works quite well. This is my GitHub commit graph. As you can see, refactoring. Like, you have to do an enormous amount of refactoring. The ridiculous week in the middle where I was 120,000 lines plus and 75,000 lines minus, part of that was just I basically had these refactoring weeks where there's another one near the beginning, and I would just refactor stuff. There was one 43,000 line single file that had to be refactored at that point as well, which is kind of the agency got there. But like, refactoring is part of the feedback loop. You don't feel you have to one-shot things. Like, you're converging on a better answer and a better program, and you've got time to do that, and you need to sit there and think, well, yeah, we made some progress, we got some features done, but what could be better still? And that feedback loop is, it's the kind of outer harness of your work, and you mustn't ignore that. Tests are really discovery tools. They're not, like, it's not that there's an answer and that if you had the right set of tests, it's there. You need to expand the tests if you're uncertain and where you're suspicious and you think there might be more errors. Work out new things you can add tests to. And, just kind of, it's part of your kind of quality control thought about, what's going on, and like, am I happy about this? Do I think this code is looking good? Or am I worried? And if it's worried, you probably want to add more tests and, kind of spend more time trying to break things, because your role is to be there and break things and get them fixed. I'm going to open source this code in a week or so when I've just finished the distributed systems bit. Again, when I'm happy with it. So if you want to have a look, sign up, and I'll send you a mail when it's ready. And we got a couple of minutes for questions.
Thank you, Justin. Any questions in the room? Please put your hands up, and I'll run over to you with the mic. There's a gentleman there as well. Any questions? One in the middle there. With the tables, it's a little bit trickier, huh?
Hi. Did you experiment with any formal verification or testing tools for the distributed system part?
Not yet, because I'm still working through it. I want to next. I'm looking at basically, I'm basically going to look at verification tools as soon as it's kind of fully implemented. I have a sort of huge transition plan from the single host to the multi-host, and like all the bits of it have been worked through, and I'm hoping like next week it'll be runnable as fully distributed, and so yeah, then I'm really interested in what I can do there, because I think there's probably going to be some bugs, and I've been looking at those tools for quite a while, and I'm really interested in that space, and what you can verify and what you can formally verify. Formal verification is like something that I love to do more of, and it's kind of something that there's mixed reports about how good AI is at it as well, and I'm really fascinated in that area, so yes.
There's one up right at the back. Oh, no, one there, yep.
Hi, thanks for that. Absolutely brilliant. It's uncanny how similar to what I'm doing, and I don't know how you will, just think about this question, but the challenge I had, and I think you are bound to have it with a test oracle, is, as you know, the AI loves telling you that, oh, that would be a tautology, because when you're building a system and you have a test oracle, the test oracle has to work on an entirely different way of doing the exact same thing with the system you're testing, so that you're not just running the logic twice, which would naturally produce the same output. So the big difficulty I had was implementing the system using the AI, and then implementing the test oracle to follow an entirely different way of achieving the same outcome, so that these two keep each other in check. So this may be just maybe we're doing entirely different things, but does that sound familiar? Did you think, or did you have to fight that?
But yeah, I mean, I think it was slightly easier because S3 was so external and like just there, and like I had some similar issues though with some of the model testing it set up, where it was like, what am I actually testing anything that's different from the code? And I think that I think that I said that I'd still build an Oracle even if I was building a complex software, but I think I'd probably build it maybe outside the repo or something as a fixed, like very dumb model of it that was, because I think you can end up in this situation where you turn out you're not really testing anything at all that's not the same as the thing you're testing, and you need to have that sort of fixed guarantee that it's what you want. And yeah, it's definitely easier when you've got an external system you're copying or something that you can really nail down that that's true.
Awesome, that's all the time we have for questions, but please give it up for Justin.